All right, this is Honors Algebra 2 Pre-Calculus. We are doing 4.4 in Algebra 2, which is solving systems of equations with matrices and a calculator, because we're going to learn how to do it without a calculator in 4.5, and you'll probably hate it, but that's cool. All right, so we've already learned three methods of solving systems of equations. Graphing, which is 3.1, substitution, also 3.1, and elimination, which is 3.2. Cool. So one of the limitations of graphing, and some of the other methods in terms of how difficult a problem is that we can't solve more than two variables that way, right? So if you think back to when we were doing graphing, right, if you go to your y equals, you have a y, you can put in x stuff, but your calculator graphs in two variables, not three. So if you have a system with 3 or 4 variables, you've got a problem. So with matrices, we can solve a system with 3 or 4 or even more variables. Like you could do 10 variables as long as you have as many unique equations as you have variables. So if, for instance, if you had x, y, and z, you would need 3 unique equations. If you had x, y, z, and w, you'd need 4 unique equations. So the setup is really similar to what we see with elimination. You're going to want to line up your equations so that you have so on the left-hand side, each column is a specific variable, like all the, so something like this, like 2x plus 4y plus 3z equals 8. I'm just making up an equation. And x plus y minus 5z equals 0, and 3x plus z equals 2, right? Where this entire side is the x's, right? Or this entire column is the x's, this column is the y's, and if there is no y, I just leave it blank. This column is the z's, I have a column with the equal signs, and on the right-hand side, I have a column of the constants, right? Notice that LHS, meaning left-hand side, and RHS, meaning right-hand side, are actual math abbreviations, not Hoganisms. So in this section, we're going to walk through how to do these problems using your calculator. Again, this is a fake problem, so we're not going to do this specific problem. I just wanted to show you what I mean by lining up your equations. Cool. So let's go ahead and move forward. So let's walk through the steps of solving with matrices. We're going to walk through this particular one, and then we'll go from there. Okay, so this is a pretty easy one. I'll be honest, I would not use matrices to do this. I'd use substitution. It is already solved for y. If you were actually going to solve this, you would substitute in the x plus 5 in for this y, and then clean the whole thing up, and it would be great. But we're going to do it using using matrices to prove how you would do it. Okay, so the first thing you do is line up your equation, which means I need to move this x to the other side. So my equation's going to end up looking like 2x plus 3y equals 10, right, on top of a negative x plus y equals 5. Okay, so there's my lined up equations. Okay, so step 1, done. Next, what I'm going to do is I'm going to make a coefficient matrix, meaning a matrix that is just all of the coefficients in front of the numbers, or in front of the variables, rather. So my coefficient matrix, A, is going to be 2, 3, negative 1, 1. Okay, that's my coefficient matrix, right, which I'm going to call A. Then I'm going to make a variable matrix. Well, that's going to be the variables in the same order they were written in, but going down. So that's going to be my variable matrix, okay? And I'm going to call that x, variable. And usually when you see this in a textbook, they make it clear that this is not the same x as the variable by making it like the serif kind of x with the Roman numeral kind of looking thing, right? And then on the other side, I'm going to say that that equals my constant matrix, which is going to be a 10 and a 5. Okay, and that's going to be my constant matrix, and we usually use B for that, okay? Now, so that's my next step. Make a coefficient matrix, a variable matrix, and a constant matrix, right? So I end up with AX equals B, right? I'm going to solve for that matrix X by multiplying both sides of the equation by A inverse, right? Meaning A to the negative first. The reason I have to do that is you cannot divide by a matrix. There's no such thing. So what I'm going to do is I'm going to take this AX equals B, right, which is what I currently have, and I'm going to multiply both sides by A inverse, right? And I'm using the calculator notation. You don't need to put the brackets around it, but I'm using. Now the A inverse is going to go in front. The reason that makes sense is that this is a 2 by 2 matrix, right? So its inverse is also 2 by 2, and this is 2 by 1. You can't do B times A inverse. You'll get an error. So A inverse times A is going to cancel, right? And I'm going to get that matrix X, right, which is my variable matrix, is going to be equal to whatever this result is, right, when I put this in my calculator. So if we were to walk through this in my calculator, right, so let's quit out of this. So if I go to second matrix, right, I'm going to edit. I'm going to make my A 2 by 2 matrix, right, that is 2, 3, negative 1, 1, right? And I double check that that's what it looks like, 2, 3, negative 1, 1, and I quit out, right? I'm going to go back to matrix. I'm going to go to edit, and I'm going to pick B. I'm going to make it a 2 by 1 matrix that is a 10 and a 5, right? I'm going to quit out, right? So now I'm going to go to matrix, and I'm going to do A inverse times B and hit enter, and sure enough, my answer is a negative 1 comma 4, right? So I end up getting, oh, that's not going to show up if I do it that way. Hold on a sec, I got a thing. Okay, so sure enough, my answer is a negative 1 and a 4. Well, that matrix, if you recall, was x over y, right? X over y. So when I'm asked to answer the question then, my answer is that x is negative 1 and y is 4, right? Because again, corresponding parts of equal matrices are equal, right? So this is the corresponding entry to here, right? These guys match. So that's kind of the idea. So what we're going to do now is we're going to walk through some more problems like that. So here's the book's actual first example. So this is the example from the book where they walk you through the same concept, but I think in a harder way because they started with a word problem. So a financial manager wants to invest $50,000 for a client by putting some of the money in a low-risk investment that earns 5% and some in a much riskier investment that earns 14% per year. How much money should be invested at each rate in order to earn $5,000 of interest per year, right? So we're going to make X the amount in the safe account, the low-risk account, and Y the amount in the high-risk account. We're going to write a system of linear equations. So we know the total amount of money that the person has to put in is $50,000, right? So that's the total cash. Right? So X plus Y, X is in the low risk account, Y is in the high risk account. You're going to invest all of it. That's $50,000. By the way, wouldn't it be nice to have $50,000 to invest? And then the second equation is the amount that's interest, right? So you're getting 5% of interest on X, so that's 0.05 times X, and you're getting 14% of interest on Y, so that's 0.14 times Y, and you want that to be $5,000. So that's your system of equations. Now, if you were going to solve this, I'll be honest, I would probably solve this using either matrices, which I think is the best option here, or graphing because it's two variables, it's got decimals, and I just don't want to deal with it. But I'm going to go, and also because the numbers are big, right? So I think matrices is the easiest way to solve this. So once you have this written up, you see how your x's are in a column, right? So here's your x's. You write your coefficients of x, which are 1 and the 0.05, right? And your coefficients of y, which are 1 and the 0.14. There's your coefficient matrix. Your variable matrix is x over y, rather, because you have x's and y's. And your constant matrix is the stuff on the other side, the 50,000 and the 5,000. So now you have this A matrix X, right? So matrix A times matrix X equals your matrix B. So if you do your A inverse times B, which we're going to do in example 1, you'll be able to solve this, and it's a really fast and efficient way to solve this problem. All right, so let's talk about why you have to multiply by the inverse. So solving AX equals B, where X is actually, where A and X and B are all matrices, is similar to solving the linear equation, right? What you would normally do is you would divide by A, or multiply by 1 over A. The problem is that there's no division in matrices, right? So you can't divide by a matrix, so you have to multiply by the inverse matrix, which is what's happening here, okay? So let's go ahead and walk through this, right? So if we go ahead and put in our calculator, our A, right, was 1, 1.05.14, right? Our X and Y, right? And then we had a 50,000 and a 5,000, right? So this is going to be my A, this is my matrix X, right? And this is my matrix B, right? So in order to find that matrix that has the X on top of the Y, I'm going to need to do A inverse times B. And really, it just becomes about entering those in my calculator correctly and then communicating the information that that's what I'm typing. So I'm even going to leave my A inverse times B that I have from the last example I did. I'm going to go ahead and go to second matrix, and I'm just going to change A and B, right? So A is a 1 and a 1 and a 0.05 and a 0.14, right? And then I quit out and I go back to matrix. I'm going to go over to edit. I'm going to go down to B, and this one's a 50,000 and a 5,000. Right, I'm going to quit out, and then look, I already have A inverse times B, so I'm just going to hit enter. So I end up with this answer right here. Right, I'm going to drag that on because I'm lazy. Okay. So what I end up getting is that since we're assuming that we're not going to put in, like we're assuming that we're going to round or truncate at the cents, right? You're not going to put a fraction of a cent in. So X was the low risk account, so you should put 22,222 and 22 cents in the low risk account, right? The one that's 5%, right? And you should put the remaining $27,777.77 in the high risk account, right? And you do want to answer the question, right? You don't just want to say X and Y equals, right? You want to go ahead and answer the full question, and that's how much the person should put in the two accounts. All right, cool. So let's do a P1. You're going to do the same basic thing. Financial manager wants to invest $50,000. Same idea in a low risk and high risk. That are the same percentages, right? They didn't even bother to change the percentages. The only thing they changed is that they want you to use $4,000 for the interest. So again, X is going to be the amount in the 5% account, right? And Y is going to be the amount in the 14% account. Right, so my equations are going to be X plus Y is $50,000, because again, boy, it must be nice to have that much money, right? And then 0.05 times X is the amount of interest I get from X. 0.14 times Y is the amount of interest I get from the Y account, and we want that to equal $4,000. What's crazy about that is it really only changes one thing in my matrix when I go to use my calculator, right? All of this is exactly the same matrices that we just used, except for one thing. This is the only thing I have to change, right? This is my A, this is my B, my X, Y is going to be that A inverse times B, right? So I'm just going to go ahead and grab the calculator again, and this time I'm going to go to second matrix. I'm just going to go edit A. Oh, I'm sorry, not A. My bad. I meant B. Go edit B, and I want that to be a $4,000 instead of 5. Right? And I quit out, and then I can just hit enter, and there's my new amounts, right? Now, it makes sense that if I want to make less money, I have more in the lower risk account. And you might say, huh, that's weird, Hogan. Why would you want to make less money? Well, the reason you'd want to make less money is if you don't want to take so much risk, right? So, sure, more money's great, but not at the expense of, you know, the idea is that's what you make if nothing goes wrong, right? And I think all of us currently working from home instead of at school understand that sometimes things like a pandemic go wrong, right? So my answer to this problem would be that I want the $33,333.33 in the 5% account, and I want the $16,666.60. Technically, we're going to go ahead and call that 67 cents, right? Because here, what's going to happen? Oh, and I should have actually rounded the last one too. This doesn't add up to $50,000. We should have made this an 8, right? Because otherwise it doesn't add up to $50,000. You end up a penny shy. Anyway, so 67 cents in the high risk account, right? So anyway, there's my answer, right? I think that might be the last one in this video. Yep. So we're going to stop this video.